Hey guys, microservices in Ktor, the Hashicorp stack, and Firebase. So I don't know how many of you guys have heard of any of what I'm going to talk about tonight, but hopefully you'll find it quite insightful. And if you guys have any questions, you can let me know in the chat. So what's in this talk anyway? So what we're going to do is go over a brief overview of exactly what Ktor is. We're going to work with two Ktor services, user management, and the London Underground API. I had to switch that. You'll see how and why, which actually that's actually a bit more interesting. Basically, how we can push Ktor Docker images to GCR, that's Google Container Registry, and then running both Ktor images in something called Nomad. That's part of the Hashicorp stack I'll go into a bit later. Registering the service in consul, again a bit later, also part of the Hashicorp stack, and testing reachability and communication between services. Okay, so who am I? So I'm Vusi, as Patani introduced me as. I'm an Android engineer at DBT. I'm actually the co-organizer at GDJ as well. I love Hashicorp products, as you'll see in this talk. A lot of the stuff is open source, which makes it really great to work with as well. Um, it also taught me how to do uh, to actually not take microservices lightly, as you'll see. Twitter-wise, you can reach me at my handle at the bottom. Okay. So Ktor, what exactly is Ktor? So Ktor is a web server framework provided by the guys from JetBrains. It is a very, very modular piece of software in that basically you swap out the different types of libraries you need depending on what you're working on, right? So if you want authentication, you put in the authentication library. If you want to work with specific client-based things, so in this, like for example, if you're calling an external web service from your server, you bring those client libraries. If you don't need them, you leave them out. So extremely modular. That results in it being extremely lightweight. Because of the modularity in nature, because not all libraries are just given in one fat sort of library, it's really, really lightweight in that in that you basically use only what you need at the time. Obviously 100% Kotlin, it's built from the ground up using Kotlin, which makes it really, really awesome. It also means that it was built from the ground up to support Kotlin coroutines. So you'll see that not just the code itself supports coroutines, but a lot of the server items as well. So basically, the server framework I use, Kotlin CIO, sorry, coroutine CIO, that's just exclusively coroutines, and then yeah, it also supports Kotlin multi-platform for the guys that are really interested in that. So our web server. So basically, we've got basically two services that I'm going to show you guys. This is basically the user API that we use. So the way Ktor works in that we build everything using extension functions. So if you guys have used Kotlin before, we use a lot of extension functions in this. Like literally, all your routing endpoints are extension functions. Um, the application module itself is an extension function, right? And so if I show you here, what we do because of the modularity nature that I spoke to you guys about, we basically need to install each feature as you go along. So if you want default headers, we install the headers. If you want to log out our particular API calls, we log that. If we want to use authentication, we log that as well. A really nice thing about it is the fact that you can basically define authentication based on different endpoints that you want. So let's say you've got, say here we've got like service auth, if you see here. So basically, because we're writing microservices, what I've done here is uh, I basically have the different services using authentication between themselves. So a service auth token will not work with a user token, for example. And then the user auth token as well is what I use basically to authenticate users and exactly how that works. At the bottom here, we've got routing. So if you guys know how basically the essence of any web service ever is that we need to route our requests via specific things. So what we do here is we install the routing specific feature, and we tell Ktor exactly what APIs we want to use our routing with. So that'll be the user API, because this is our user service, and service API. So as you can see here, if I go to the user API, you'll see that it's literally just an extension function of of the routing framework. Okay, and then at the bottom here, it also supports things like rate limiting. We basically it's just a way of us limiting our requests, so we don't have a lot of spam requests as well. Content negotiation. Here I use JSON. For you Android developers out there, this will be very, very familiar to you. So it's a way to serialize and deserialize a lot of our JSON requests. We also use Firebase in this user service. So you see here, what I do is actually initialize Firebase, and I use Firebase to basically verify that a user exists in Firebase before we service any requests. That way we know whether if a user doesn't exist or not in our service, then we can either reject or continue with the request. Okay, so that's basically a short overview. The next thing is, so that's just a really, I know it was a very sort of in-depth, but not really look at Ktor. But we'll see how, because I've only got 20 minutes, I want to get through as many things as possible and show you guys exactly how we can bring up microservices with services written with that framework in mind. So how are we going to retrieve data to and from our services? How exactly does all this flow work? So basically, we expect the user to log in using the mobile phone. They log on to the user service, as I've shown you. The user service will essentially return a token response. That's basically a JWT token. As I said earlier, we swapped out the London Underground API for a dummy receipt service that I was playing around with. Basically, so instead of retrieving things about trains, now we get information about receipts that we've saved on this receipt app that we have, generic receipt app that we have. So what happens is the token response is sent back by the user service. Then we get our receipts from the user service. From the receipt service. Now this is very interesting in that these two are going to communicate. So essentially, what happens is, as I said here, what we do is when the user logs in, right? We need to verify that first of all that the token is legit, that it's authentic, and that the user actually exists. So we essentially verify that the JWT token, retrieved from the user service is legitimate, and we do that using an external service using auth-o. Then the next thing we do is that we verify that the user does indeed exist in our system by talking to the user service about it. Then basically this will then go to sorry about that. Yeah, so essentially this is what we do, and then we return data to the user. Once these two are done, the receipt service then returns data to the user from a MongoDB instance. Okay. So how are we going to get our services to speak to each other? So this is the crux of the matter, really. So we've got our two Ktor services up and running. That's a receipt service API, and that's a user service API. Cool, extension functions also holding good. But we often hear this term microservice, and sometimes I feel like it's used a bit loosely, in that people actually need to figure out exactly how this works. So this is something called consul. So consul is an open source service mesh tool from Hashicorp. Service mesh basically meaning how do we get our services, how do we get a whole bunch of services, a group of services to speak to each other, and this is what consul facilitates. It helps find the services within so services within consul can basically find each other. It works across any sort of IT infrastructure. So we have an internal infrastructure, external. You've got a bunch of Ktor services running in or out your organization. You may have different cloud providers, Google Cloud, Amazon, etc. Consul works across that. Your Ktor services will be able to find each other regardless. If your Ktor stuff is running on top of Kubernetes, it will work there as well. And we no longer need to know about IP addresses. I know this sounds like a really solved solution because we've already got DNS to do that, but I will show you why this is a very, very important point. Okay, so service mesh in 5. So how this actually works is that traditionally we have an external service that goes to some internal application, which is a monolith service, which basically is either is a fat jar or some other thing, right? So it could be like one Ktor application that's written with a whole bunch of functions that does. So instead of, for example, having the receipt service and the user service separate, they're together, right? And they're usually hidden behind maybe one IP. Okay. Now, instead of what we do here is that when we deploy these microservices, we now have the services split between each other. So as I showed you earlier, it would be a receipt service, or it would be a user service, etc. We split across them, and then we've got different IP addresses. Obviously, this now presents a problem because now we've got all these different services, and let's say there are 3 user services. We're going to have an issue of, okay, which one does the user hit first? What happens if service 1 just goes online, is flapping in the sense it goes online and offline all the time? Scaling also becomes the issue. You know what I mean? And then the third issue that we may have when you have one service split like that, or multiple services split like that, is the fact that now you could say, fine, we can solve it using a load balancer. This is already a solved solution, Vusi. What are you talking about? So yeah, we can have a load balancer, right? But the issue is now that we have an extra hop in our network to get to those Ktor services. Secondly, now it represents a single point of failure, in that if this load balancer goes down, then all our Ktor services are down. Okay, so how do we solve this problem? Because as well as you can see in this slide as well, you can have multiple services as well. What happens here is something looking like this, where you've got the user service here and receipt service over here, and they need to talk to each other. How is this going to work? How does this one know that this one's down? And how does this one know that it's servicing a million other requests, X and vice versa? So now this becomes a big issue. And this is where we see that microservices are also bringing their own bit of headache as well, which also we need to solve. Luckily, we've got consul for that. So yeah, what if we could have our services discover and talk to each other automatically? Okay, so basically this is what consul would help us with, in the sense that our services now register themselves in consul. It could be like, so for example, we have our user service and we've got our receipt service, packed individually, distributed across maybe Google Cloud, deployed using GCR and all the other fancy tools. What we can do is that we can get Ktor to register itself with a consul instance, right? What that basically means is it says, hi, I'm a user service, and you can find me at this particular DNS name. So the point that I raised earlier about what happens if, like now we don't have to use IP addresses. Consul essentially allocates DNS names to each service that registers itself. So now we no longer have the issue of load balancing or etc. because consul will say, okay, user service 345, I'll give you user service 345.service.consul. Okay, so basically consul, what it'll do is it'll basically give you DNS names under service.consul moniker. So all your services, whatever the service name is, will find itself under basically service name.service.consul. And that will allow our separate Ktor services to essentially be able to find each other. If the service goes down, the Ktor service, then a consul will basically automatically remove that from commission. And then the rest of the network knows basically not to route service requests there as well. Okay. We can see the scalability in that, for example, if we decide to run 10 instances of our service, that's perfectly fine. We can run 1,000 instances, we can run 10,000 instances, we can run 1,000,000 instances spread across multiple geographies. And something like consul will be able to look at that and be able to give each one a reachability context in terms of service name, reachability, DNS name, is the things that service, how you want to split traffic across, etc. Okay. Now, the next tool that helps us achieve this sort of reachability to the services is that we actually want to do Docker containers, right? So what we can do with Ktor is we can package all our containers basically package all our services into a Docker instance, right? And what we can do with that is we can deploy it into a container orchestration tool called Nomad. So Nomad and Consul are very, very tightly integrated with each other. So what you do with Nomad essentially is that you basically describe it. You basically describe your service, exactly where you want to run it. how many containers you want, which is what the count is, the restart attempts you want for the service. So let's say you want to say, for example, if I attempt to restart the service more than 3 times, you need to fail the service. Okay, so that way we know that there's something definitely wrong. You can see here with Docker, what we do is we then pull the image from GCR, and we basically describe. And then what we do with Nomad is that we basically tell it exactly what port to map our service to, because when we deploy our Ktor instance, we then basically tell it what port we need, and no, no, Nomad will then do the magic. Okay. What happens now is when we deploy in Nomad, it then tells us that cool, if our Nomad deployment is successful, we then have our 10 containers that we basically wanted earlier over there. Now all 10 containers are deployed successfully, and basically what happens here is that Nomad will then register everything in console. So basically here, so Nomad will essentially show that cool, this is where that registered via Nomad comes from. We've got 10 instances, and these are some of the tags that we can use. So basically, when you look it up via DNS, it will be called something like we're on tube.service.console. Okay. Or basically user service.service.console or receipt service.service.console. Basically what I explained earlier. Okay. Cool. And then how do we ensure that everything is reachable? Okay. So let's say we've taken this container thing a bit too far with Nomad, and consul's doing its console magic of making everything reachable. How do we make sure that if we spin up 1 million containers, all those 1 million containers are reachable? Okay, so this was the third thing in my intro, which was basically Ktor, Hashicorp stack, and Fabio. The last thing we need to talk about is Fabio. Okay. Fabio is a load balancer, but different from the conventional one that we did speak about earlier. I know everyone will be like, wait, you said load balancers are bad. Not all load balancers are bad. So Fabio works exclusively with console as well, in that it is absolutely zero configuration. So whatever you find in console will then be loaded into Fabio. Okay, so Fabio basically waits for console to tell it, okay, so I've got 1 million instances of the receipt service or 1 million instances of the London Underground service. This is all the information you need. Basically, Fabio will then take that, load it into the routing table, and then essentially make sure that those services are reachable. This alleviates a lot of stresses, namely, we don't care what port any of our Ktor services run. We don't care what system any of our stuff runs. Fabio and Nomad and Console, that entire software stack does everything for us. It finds a system with available resources. It then deploys that system, and it then whatever. We don't care what ports are. We just want our app to run, and we just want our app to be reachable, whether we have 1 million instances of one. Fabio will then make sure that whatever service is very important, advertised as healthy, is then advertised to the outside world and is shown that it is reachable. Okay. The only thing we need to do with Fabio from a console perspective is make sure that we add a URL prefix to our services. I'll show you what that is. So remember this thing I showed you earlier of our service, which is now registered via Nomad. The URL prefix is basically something that tells us what path we need to go to for that particular service. Okay, so in this example, we know that if we want to access anything to do with the way around tube service, we know that we access it via API/v1/underground. We don't care what comes after underground. We assume that it's underground/x. Okay. As long as we know that we've registered our service in console with that particular prefix, then we can Fabio will make sure that it'll route all the traffic directly to that particular instance. Okay. What happens is now that when Fabio now advertises as a successfully deployed instance of something, you can see like here a whole bunch of IP addresses we don't care about, a whole bunch of ports we don't care about. We do know that what we need to look out for is make sure that all these are basically found under here, and this is the weight distribution across each service. Okay. So Fabio makes sure that each service advertising console, as long as it's healthy, again, I will iterate, because unhealthy services will not be advertised, which essentially means that if your service is not reachable or is not seen in Fabio, then we know that there is something wrong with the service itself. You can gracefully go have a look at that without assuming that any of the other stuff you worked with before is not working. Okay. Yeah. So, okay. Yeah, so I know this is a super lightning talk, and I do want to do an in-depth talk at some point, but there's a lot of stuff that I went through, and I do understand that, but I really just want to highlight that we can deploy Ktor in basically over 1 million containers and make sure that it's reachable. Yeah, so what have we seen? So with the ease of using Ktor, we can get any number of services up and running relatively quickly using a consul, Fabio, Nomad trio, right? We're also able to launch them at scale, ensuring, and we can also, like, we make sure that whether we're using bare metal, laptop, using your MacBook, or using servers from digital or whatever, GCR, whatever it is, as long as that operating system is running on basic is can run Docker, it can run console and Nomad. Okay. Um, with the ease of deploying our Ktor services on private repositories like GCR, we can deploy our services as containers really quickly. And also because Ktor is running Kotlin code sharing between application and servers and everything is between basically Android, has it been easier? Yeah, so I know this is a very super lightning talk. I know I glossed over a lot of some of these in-depth concepts. If anybody wants me to do like maybe a series of blog posts, I'm just trying to put everything together for that. But if you guys are interested in learning more, please let me know. This is a very cool piece of tech. Ktor is absolutely amazing for something like this, in that you can actually get the services to speak to each other, and it's no longer microservices as this little abstract concept. We can actually put it into sort of good use, and we can do it at scale. Which for me is, if I can't scale an application, then I don't know what I'm doing with it. That's sort of my mantra when it comes to backend services. Yeah. So yeah, that's pretty much it. Again, I know I spoke really fast, but I hope you guys really enjoyed that. A brief look at microservices at scale using Ktor, and yeah, thank you very much.